In this lesson, we are going to discuss the process of converting general form of a quadratic function to vertex form so that we can easily identify essential elements of its graph without actually plotting the graph. Let's get started with the general form of the quadratic function. So, general form of quadratic function. Quadratic function is ax square plus bx plus c equal to h of x. If this is the quadratic function, we want to convert it into vertex form. For that purpose, we'll complete the square. By completing the square, and square completing method requires us to first of all make coefficient of x square equal to 1, which we can do. So step 1, make coefficient of x square equal to 1, and for this purpose what we are going to do is h of x equal to, we'll take a common. If we take a common, we can do so like this, plus a times bx divided by a. If we multiply and divide, it doesn't make any difference in the equation. Same thing with third term, which is c. We divide and we multiply a as well. And now we can take a common. If we take a common, now what we are left with is x square plus b over a x plus c over a, because a has been common throughout all three terms. And once we have coefficient of x square equal to 1 inside the bracket, then the second step, step number 2. Step 2 is that in rough area, we write down coefficient of x. Coefficient of x is plus b over a, and we multiply it with 1 by 2 and then take the whole square. We add and subtract it. So this in fact will become plus b over 2a whole square. This is what we will add as well as subtract. So let's write that down. A times x square plus b over a x. We are going to add plus b over 2a square, and we will also subtract minus plus b over 2a square. If we add and subtract something, it doesn't alter the value of equation or function. So plus c over a. And by placing the bracket here, now if we take a look at the first three terms of this, the first three terms, they are a perfect square of two square terms. This is equal to a times x plus b over 2a square, and then we have plus c over a and minus b square over 4a square. This was our intention to make full square term, and we have done that. And now we are going to make the constant term after the square term. Let's do that. So a time x plus b over 2a square, and now we are going to take LCM for both of these. LCM is 4a square. A will get cancelled and 4a will multiply with c, so that will become 4ac minus b square. And then we multiply a from outside, and this gives us a time x plus b over 2a whole square plus a time 4ac minus b square divided by 4a square. A will get cancelled with the square, so this will become equal to a into x plus b over 2a square plus this square will get cancelled with this a, leaving behind 4ac minus b square over 4a. There is only one thing that we need to do before we can declare its form, and that is we need negative sign right after x. So what we do here, x minus, and we place another minus inside with b over 2a so that we don't disturb the equality. So this square plus 4ac minus b square divided by 4a. This is comparable now with the vertex form. Comparing with h of x equal to a into x minus h square plus k, which is vertex form. And we can see that this takes the value of k, and here whatever minus b over 2a, that is being replaced by h, and a is comparable to a. So the vertex hk, so the vertex equal to hk is same as minus b over 2a minus b over 2a, and instead of k what we have is 4ac minus b square minus b square over 4a. This is vertex, or equivalently it is relatively easier to find just the x component of the vertex and then find the value from the function. It's r, you can write it minus b over 2a, and f of minus b over 2a. So whichever way you can either directly find the vertex hk by putting x equal to minus b over 2a and y equal to 4ac minus b square over 4a, or you can just find x and then substitute the value of x into the equation to find the image of x. For example, here let's do this example. If the function function h of x is equal to x squared minus 2x plus 5, then a would be equal to 1 because the coefficient of x squared is always a. B is equal to minus 2 and c is equal to 5. So we will do both ways. So option 1 is that vertex would be equal to minus b over 2a. So what is value of b? Negative, and then b is minus 2 divided by 2 times a is equal to 1, and then draw the line 4ac. 4 times 1 times c is 5 minus b square is negative 2 square over 4a. 4 times 1. So this is value of vertex. This is equal to 2 over 2 comma 4 times 5 will be 20 minus 4 over 4. So this will be equal to 1. 16 by 4. 16 by 4 will be equal to 4. So the vertex is equal to 1, 4. Or option 2. Option 2 we can do this way. We don't calculate the second part. We just calculate the x. We only calculate h, which is equal to minus b over 2a. And minus b over 2a is equal to minus negative 2 divided by 2 times 1 is equal to 1. So once we have found h, then we will find function. Value of function at 1 is equal to x squared, mean 1 squared minus 2 times 1 plus 5. And this is 1 minus 2 plus 5, and that is equal to 6 minus 2. This is equal to 4. So this is equal to k, which is here, that is equal to 4. So this way, in fact, we should have written k over here, and this way vertex is equal to hk, or it is 1, 4. So either way you can see that whichever way you calculate, you can always find vertex, and it's not hard to convert any general form of quadratic function into vertex form. And if we want to discuss other elements of this, we can certainly do that. For example, x-intercept. X-intercept we have already found. We have found x equal to minus b plus minus b square minus 4ac over 2a. For x intercepts of the quadratic function. Ax h of x equal to ax square plus bx plus c. Similarly, we can find all other elements of the graph of the quadratic function simply by converting a given form into vertex form.